So what we're going to look at is proving the product rule. So if you're doing methods in Victoria, at least what they'll do is they'll introduce you to the product rule. They'll expect you to know how to use it, but they won't necessarily explain where it comes from. And I think it's yeah, completely understandable where it comes from. You just need to have an understanding of differentiation by first principles and a few properties of limits, which we'll look at. So basically, this is what we're trying to show. We're saying that if we've got some function f of x that is the product, that means the multiplication of two functions u of x times v of x, and the derivative of that function is equal to u of x multiplied by the derivative of v of x plus v of x multiplied by the derivative of u of x. On the methods formula sheet, it'll show you this. So you need to be familiar with this, the way it's written here. It's basically saying u and v are both functions. So the derivative of u times v is equal to u dv dx or plus v du dx. Same. I'm just going to use this notation because it's a bit neater when we do everything. Okay, so I'll put some links below in terms of prior knowledge you need for this, but I suppose the key thing is this. You need to understand that the derivative of a function is given by this. The limit as h approaches 0 of f of x plus h minus f of x all over h. And then what we want to do is we just want to apply these first principles to this, to f of x equals u of x times v of x. So essentially, that is our function f of x. So we're going to sub that in. So what we're going to get for f dash of x is going to be, all right, well, it's going to be u of x plus h times v of x plus h minus u of x times v of x all over h. Okay, so that can be a bit confusing to look at, but essentially we've just made a substitution. F of x plus h is just this first part because f of x is u of x times v of x. So that's just this first part. F of x plus h is u of x plus h times v of x plus h minus f of x. Well, f of x is just u of x times v of x. So that part's hopefully a bit simpler. Okay, and then we just got to do a few interesting things. What we're going to do is we're going to leave a big space here and we're going to do something kind of like a trick. But I don't like to think of it as a trick. Remember, in maths, you can do whatever you like as long as you don't break any rules of maths, right? So what we're actually going to do here is we're going to do the following. We're going to subtract u of x plus h times v of x and then add u of x plus h times v of x. Hopefully you realize that that is essentially adding 0. I haven't changed anything there. This all equals 0, so I haven't changed this previous line. We're just doing this strategically. And the reason we want to do that is because we want to take out common factors. So let's have a look. In this first part of this equation, so from here on, we've got u of x plus h as a common factor. So we're going to take that out as a factor. So we're left with u of x plus h out here, and then we're going to be left with, all right, we'll be left with v of x plus h minus v of x, this v of x. And then similarly over here, if we look at the second half of the fraction, we've got v of x as a common factor. So that comes out the front, and you're left with u of x plus h minus u of x all over h. So hopefully that part, you can see why we needed to do that, because this is what's going to happen from here. We're just going to separate these fractions. We're just going to break them in half. So yeah, that's all I've done there. I've just broken it, split it in half. And then what we can do is the following. So there's a few things about limits we need to now know. The first is that the limit of a product is the product of the limits. So what that means is this u of x plus h can come out the front, and we take the limit as h approaches 0 of u of x plus h multiplied by all the other stuff that's left. So you're going to be left with the limit as h approaches 0 of v of x plus h minus v of x all over h. And a similar thing goes on here. Bring the v of x out the front, and then you're left with, yes, and then you take the limit as h approaches 0 for that, and then you multiply by the limit of u of x plus h minus u of x all over h. And then, yeah, hopefully you realize now, all right, let's just look at this first part here. The limit as h approaches 0 of u of x plus h. Well, if h is going to 0, this is just the limit of u of x plus h. One sec. So I just recognized an error. And just over here, I had an error. So basically, this first part here, the limit as h approaches 0 of u of x plus h. Well, h is approaching 0, then you're just left with u of x. So that's that first part. Right, this second part is just the derivative of the function v of x. Hopefully you can see how this is similar to this part here, just with v's instead, right? So this second part here is v dash of x. Okay, this part here is the limit as h approaches 0 of v of x. Well, there is no h in that, so that's just v of x. And then this part here is the derivative of u of x, so u dash x. So we get our conclusion that, that the product rule is what it is, and it is what we said it was at the start. To find, the derivative of a product of functions, you take u of x times v dash of x plus v of x times u dash of x. That probably sounds like a complete other language, all of that stuff, but hopefully that made some sense when you step it through. The other thing to say as well is that we mentioned a property of limits in there, which is that the limit of the product of two functions is equal to the product of the limit of those two functions. I think I said that right. And similarly for the sum. So you notice like this limit got applied to this whole expression as well. I'll put some links below so you can explore why that's the case as well. But I can guarantee you that, again, similarly, and I've got to say this right, the limit of a sum is equal to the sum of the limits. So that's not necessarily obvious, but there's some properties you have to use in order to prove the product rule. So hopefully that clarifies things. I'm just going to check a problem here, if you can try it out if you like. So use the product rule to find the derivative of the following function, 3 minus x squared multiplied by x plus 4. Let me know what you think, and let me know why using the product rule might not be the best idea for this type of problem. But obviously you can still do it. I encourage you to think about what the two functions are. Okay, good stuff. Hopefully that explains some things for you.